In this lesson, I'll show you how to use Euler's method to graphically and numerically solve differential equations. Question 1 reads, use Euler's method to graphically solve the differential equation dy over dx is equal to x over y squared from the boundary value 1 and 1 to x is equal to 5. Increase x in steps of delta x is equal to 1 unit. The first thing that you have to do to solve this graphically using Euler's method is plot the first point, 1 and 1. So I'll plot it right here. And next what I'll do is substitute these two coordinates into my differential equation, where I have dy over dx, which represents my slope, is equal to 1 over 1 to the power of 2. That is equal to 1. So I'll take this as my slope, where 1 is the same thing as 1 over 1, which is rise over run, and plot a point at 2 and 2. Because if I rise 1 over 1, that's 2 and 2. So I have a point at 1 and 1 and 2 and 2. Next what I'll do is take the points 2 and 2 and substitute that into my differential equation, where I have dy over dx is equal to 2 over 2 to the power of 2 is 4, which is 1 over 2. This represents my slope, and of course I can represent this as my rise and this as my run, although I'll make 1 over 2 as my rise and 1 as my run, because I want to keep it consistent with steps of 1 unit. So this will rise half upwards and then to the right once. This makes it our next point at 3 and 2.5. Like before, I'll take 3 and 2.5 and substitute it into my differential equation. So I have dy over dx is equal to my x of 3 and my y of 2.5 to the power of 2, 3 over 6.25. Reducing this fraction should give us 0.48. 0.48 is our slope, or 0.48 over 1. So I'll rise up 0.48 and run once. My next point will be at 4 and 2.98, or approximately 3. I'll do this one last time so that I can reach x is equal to 5. And I'll do my work below. Dy over dx is equal to 4 over 2.98 to the power of 2. I'll use my calculator for this one. I have 4 over bracket 2.98 to the power of 2. Hopefully you can see. And that gives me 0.45. 0.45 as my rise, and my run is 1. So I'll go up 0.45. That makes it around, well, let's try to be accurate here. I'll add this number to 2.98. That gives me 3.43. So my next point, which is at 5, will have a height of 3.43 and an x coordinate of 5. Our last step is to connect these points. If you would like to see the solution to question 2, where we actually perform the numerical method as opposed to the graphical method, make sure to watch part 2 of this lesson. We'll see you soon. And that is how to use Euler's method to graphically solve differential equations.